Alright, so this is our Honors Chemistry lesson video for section 9.2. So if you watched the lesson video for section 9.1, then you saw I had a periodic table that was color-coded with 4 colors. Hydrogen was one color, our regular metals, which are groups 1 and group 2, and aluminum were a different color. The transition metals in the middle, under the stair step, and the lanthanides and actinides at the bottom were a separate color, and then our non-metals to the right of the stair step were a separate color. So in the first lesson video for 9.1, I taught you how to name compounds that start with regular metals. So in section 9.2, we're going to talk about how to name compounds that start with a transition metal or other element that can have more than one charge. So transition metals can have multiple charges, so you can't tell the charge just based on what group it's in. Since transition metals can have multiple charges, we use a Roman numeral to indicate the charge. So just as a friendly reminder of Roman numerals, these are 1 through 5. Notice I'm not showing you more than 5 because you're probably not going to see more than 5. Even 4 and 5 are pretty uncommon, but seeing more than that would be even more uncommon. And so in here we won't see anything greater than 5. So like if you feel like you should have a Roman numeral of 8, then just kind of reassess what you're thinking. Okay, and so our names will look like this. So this is iron, Roman numeral 2, chloride. So we'll have a Roman numeral in the name. So many transition metal ions exhibit colorful compounds and solution. So transition metal compounds are known for being colorful. So they're used in a lot of paints and dyes. And so a lot of other compounds, they're just white, not really exciting. So when you name compounds that start with a transition metal, you should always balance the charges, that's commonly forgotten, to figure out the charge of the transition metal. Remember to add I to the anion if it's not a polyatomic ion. So in other words, we're going to use the same rules that we use for naming with a regular metal. We just name the metal, add I to the non-metal unless it's a polyatomic ion. But now we just have a Roman numeral in the middle. Okay, and so this is how it works. So let's say I have CuO. I know Cu is copper. I know it's a transition metal, so I'm going to leave some parentheses for my Roman numeral. And I know O is oxygen, but because it's listed second, I'm going to call it oxide. Now I can't look at the periodic table and tell what charge Cu has because it's a transition metal. So anything in the transition metal category, the lanthanides, actinides, and even under the stair step, even though we've labeled those columns, if it's not aluminum and it's under the stair step, it can still have multiple charges. So we have to figure out what the charge of copper is. So the Roman numeral is the charge of the metal. So we know oxygen's -2 because we can look at the periodic table and see that. And we know the charges have to cancel. So if oxygen's -2, copper has to be +2. And so that means it would be copper 2 oxide. Now the problem is you all want the Roman numeral to be the subscript. So like when you see CuO, you want to call it copper 1 oxide because you see 1 copper atom. Like you see a subscript of understood 1 right here. It's not the subscript, it's the charge. So even though you don't see a 2 anywhere in the formula, that's because we don't normally write the charges in the formula. Alright, so the charge is the Roman numeral. It's not the subscript, it's the charge. So let's look at a couple more. To see like this one, most of you want to call copper 2 oxide because you see copper, you see a 2, and you see oxygen. But remember, it's not the subscript, it's the charge, so we have to figure out what that is. So first of all, we know Cu is copper, and since it's transition metal, I'm going to need a Roman numeral, and we know O is oxygen, which we're going to call oxide. So we can't look at the periodic table to see what Cu is, but we can look and see that oxygen's -2. So what cancels out a -2? A +2. But notice I wrote that really high. The problem is I have a subscript here. So that means I need 2 positives, but I'm going to split them between 2 coppers. It's like if I had $2 and I said, hey, I'm going to split these $2 between you and your best friend. How much do you each get? You each get $1. So the same thing happens here. I have 2 positives. I'm going to split it between 2 atoms so they each end up being +1. So this one actually ends up being copper 1 oxide. And so like I said, that's what throws you off. You want it to be the subscript, but it's the charge. Alright, so let's look at another one. So now we have a subscript on our other element. So we know Fe is iron, and since since it is a transition metal, can have multiple charges, I'm going to leave room for my Roman numeral. Cl is chlorine, but I'm going to call it chloride since it's second in the formula. I know it's negative. All right, so we don't know the charge of iron, but we can look at the periodic table and see that chloride has a -1 charge. But I have 3 of them. So like each one has a -1 charge. So in total, I really have -3. And so again, because that's not the charge of chlorine, I'm going to write it up high. So I have 3 negatives I have to cancel out. So what can cancel out a -3? A +3. So my Roman numeral for this one would be 3. So it's iron 3 chloride. Now it gets a little tricky though, because notice I've been looking at those subscripts. It gets a little tricky when there's a polyatomic ion. Okay, so what I like to do for polyatomic ions is circle them. So I see SO4, so I'm going to circle it. I'll tell you why in just a second. All right, so we know Pb is lead, or hopefully you knew that. So Pb is lead, it's under the stair step, but remember those elements can also have multiple charges. It's not just the groups 3 through 12. SO4 is called sulfate, that's on your polyatomic ion sheet, and so again, notice I'm not going to change the ending. Now we don't know what charge lead has, but if you look at your polyatomic ion sheet, SO4 has a -2 charge. So a lot of you, once you see this, how I did 3 times -1 gives me -3, you're tempted to do 4 times -2 gives me -8, and then you want to say lead has a +8 charge. Well, remember, I told you, you're not going to really see over +5, so that should be a red flag there of, hey, I'm doing something wrong. So what are you doing wrong? Well, SO4 is all one ion. Like sulfate is SO4. So like when you see SO4, you're not looking at 4 ions, you're looking at 1 ion. So SO4 all together has a -2. So that's why I like to circle it, because then I can see this is -2. So what cancels out a -2? A +2. So in this case, it would be lead 2 sulfate. Okay, so like I said, just circle those polyatomic ions to help you remember that it's just 1 ion. So you don't need to multiply using that subscript. Now, can you have more than 1 polyatomic ion? Of course you can, but then it will be in parentheses. And so then you can see, oh, I have more than 1. I do need to multiply the charge this time. All right, so for the next couple, go ahead and pause the video and try these on your own. I'll go ahead and tell you the last one is commonly missed. All right, so I'll assume you've tried them, and let's look at them together. So Pb again is still lead, and S is sulfur, which we'll call sulfide, since it's the second element in the compound. So I don't know the charge of Pb because it's under the stair step, so it can have multiple charges. But I can look up the charge of S. It's -2. I have 2 S's though. So 2 -2's is really -4. So what cancels out a -4? A +4. So this one is lead 4. And remember, 4 is IV. VI is 6. So don't get those backwards. So hopefully you got that one right. All right, so our next one, Zn is zinc. It is a transition metal, can have multiple charges. So I'm going to put my parentheses right here. And then C2H3O2 is acetate. That's on your polyatomic ion sheet. All right, so for this, we don't know the charge of zinc. I mean, unless you've memorized that it's +2, but you don't know the charge of zinc, but you can look at your polyatomic ion sheet and see that this whole ion has a -1 charge. So I've circled the whole ion. But I actually have more than 1 this time because it's in parentheses. So see, I have 2 negatives. So that's really a -2 charge. So what cancels out -2? A +2. All right, so since that is our charge, that becomes my Roman numeral. Now, not every single transition metal or metal in that section can have more than 1 charge. A lot of them can. But I expect you to use a Roman numeral for them unless you're planning on memorizing all the possible charges for all the elements in that section. So if you would prefer to do that so you can skip a couple of Roman numerals, you're more than welcome to. But unless you memorize what possible charge every element in that section can have, then even if it's an element that can't have more than one charge, I'm expecting you to put a Roman numeral. So if you're watching this and you're not in my class, you might want to check what your teacher would prefer. All right, so our last one. Ooh, I hope y'all got this right. Starts with AG, which hopefully you already knew was silver. Hopefully nobody put gold there. Okay, again, it's in the transition metals section, so I'm going to put a Roman numeral. And then PO3 is phosphite. So make sure you pull the right word. Okay, phosphate is PO4. Now we don't know the charge of silver because we can't label that column. It's in the transition metal section. But we can look at our polyatomic ion sheet and see that PO3 is a -3 charge. PO3 is all one thing. So don't multiply and get -9. PO3 phosphite is all one thing. So what cancels out a -3? A +3. But we have a subscript down here. So remember, if you have a subscript down here, you just need to take your charge and split it between them. You're just dividing. So +3 divided by 3 is 1, +1. So you should have gotten silver 1 phosphite. So hopefully you did. I get a lot of people who give me silver 3 phosphite. All right, silver 1 phosphite for that one. So some people, they get really hung up on the Roman numerals, but it just takes some practice. The more you practice, the better you'll get at it. The better you get at it, the easier everything else will be. So there's my answers. So when writing the formula for a compound that starts with the transition metal, surprise, surprise, you have to balance charges. Okay, so if I give you vanadium 5 fluoride and you give me VF, it means you didn't balance your charges. So remember, the way you tell the charge for the first part, it is the Roman numeral. So vanadium 5 means the V has a +5 charge. Then you can look at the periodic table and see F is -1, and then you can cross your 5 down. So that's how you would end up with VF5. So remember, the Roman numeral is the charge, not the subscript. Okay, a lot of you, you'll give me this as your answer, V5F, which that's all great and everything if you don't want to get it right. But it's the Roman numeral is the charge of the metal. It's not the subscript. Okay, so let's look at a few going the opposite way if I give you the name. So we have tin, 2 permanganate. So tin is Sn. And remember, the Roman numeral is the charge. So it has a +2 charge. Because remember, it's in that category where you can have more than one charge. Permanganate is on your polyatomic ion sheet. It's MnO4 -1. So +2, -1 don't cancel. I need to cross the 2 down, but since this is a polyatomic ion, I have to put it in parentheses. All right, so our next one, mercury 1 oxide. So hopefully you know mercury is Hg. The 1 tells me the charge, so it has a +1 charge. Oxide is just oxygen. It has a -2 charge because it's in group 16. And so then +1, -2 don't cancel, so I cross my 2 down and get Hg2O. And last one, vanadium 2 hydroxide. So vanadium is V. The 2 is the charge. So it's vanadium with a +2 charge. Hydroxide is on your polyatomic ion sheet. It's OH with a -1 charge. +2 and -1 don't cancel, so I need to cross the 2. So a lot of you give me this right here. The problem is OH is a polyatomic ion, so it doesn't matter that it doesn't already have a subscript. It still needs parentheses. Okay, there's a difference in this and this. This is 1 V, 2 O's, 2 H's. This is 1 V, 1 O, 2 H's. So any polyatomic ion, even if it doesn't already have its own subscript, has to be in parentheses. So don't forget that for hydroxide. A lot of people find it easier to write the formula with the transition metals than writing the name. All right, so maybe pause it, try these on your own. I'll assume you've done that, and we'll look at them together. So we have gold 2 iodide. So gold is Au. The Roman numeral is the charge, so it has a +2 charge. Iodide is I. It's in group 17, so it has a -1 charge. So I would cross my 2. So hopefully you got that one right. Next one is vanadium 4 nitrite. So vanadium is V. The 4 is the charge, so it has a positive 4 charge. Nitrite is on your polyatomic ion sheet. It's NO2 negative. So nitrate is NO3, nitrite is NO2. Positive 4 and negative 1 don't cancel. I need to cross my 4 down, but since it's a polyatomic ion, I just need to put it in parentheses. All right, so hopefully you got those right. Last one, kind of tricky. I always like to say those tricky ones for last. So let's see if you got this one right. Silver 1 nitride. So silver is Ag. The Roman numeral indicates the charge, so it has a positive 1 charge. So what's nitride? Is it NO2? Is it NO3? Is it NO4? No, it's none of those. It's not a polyatomic ion. For some reason, all of a sudden, you all think that's supposed to be a polyatomic ion. Remember, the polyatomic ions end in ite and ate. Nitride is just nitrogen. Like oxygen becomes oxide, nitrogen becomes nitride. So it's just N. N is in group 15, so it has a negative 3 charge, so I just cross my 3. And that's it. So hopefully you got that last one right. Like I said, those nitrides will trick people. So there's my answers. Alright, so section assessment. This one's super short. It just says write the formula for chromium 3 nitrite. So chromium is Cr. The 3 indicates the charge, so it has a positive 3 charge. Nitrite is on your polyatomic ion sheet is NO2 negative 1. So positive 3, negative 1 don't cancel. I need to cross the 3, but since this is a polyatomic ion, I just put it in parentheses. All right, so whenever you're naming a compound that starts with a transition metal from groups 3 through 12, under the stair step but not aluminum, or one of the lanthanides or actinides at the bottom, you need to include a Roman numeral to indicate the charge.